Hi everyone, my name is Min Junyu. Today, I will show you how to build a movie recommendation system using Milvus Lite, which is a vector database optimized for similarity search. I will use Python programming language and a Jupyter notebook to show this demo. We will go step by step. Setting up the database, defining a schema, inserting movie data, generating embeddings with a language model, and finally performing semantic search. By the end, you will see how Milvus can help you quickly find movies similar to a natural language query. Before we jump into code, let's talk about why we use vector database. Traditional databases are great for exact matches or structured queries, but what if you want to search by meaning? For example, find movies about time travel, or movies with a love story and adventure. That's where vector search comes in. Each piece of text can be converted into a vector embedding, a numerical representation that captures its semantic meaning. Milvus stores these embeddings efficiently and allows us to find the most similar vectors quickly. Let's start by setting up a Milvus client. I'm using a local database called movierecommendations.db. Milvus Lite is perfect for demos or small-scale projects. But if your dataset grows to thousands or millions of movies, you would typically move to a Milvus standalone or cluster deployment. Standalone still runs on a single machine but allows more data and better persistence, and it can easily be deployed with Docker or Kubernetes. For truly large-scale datasets, a distributed Milvus cluster is recommended. With the client ready, we can move on to creating our collection. In Milvus, a collection is similar to a table in a traditional database, and a schema defines the structure of the data it contains. For our movie collection, we have 4 fields. ID, which serves as a unique identifier for each movie, embedding a 384-dimensional vector that represents a movie description and is crucial for performing similarity search. Title, which stores the movie's name, and genre, which indicates the movie category. To optimize search performance, we also create an auto-index on the embedding field using L2 distance, which measures how close two vectors are in space and allows Milvus to efficiently find the most similar movies. Now our movies collection is ready for data insertion. Let's insert some sample movies. Each movie has a short description capturing its plot. For example, the movie title is The Matrix, and it is about scientific action with virtual reality. In our case, to keep things simple, we are just storing the movie description in the title field and setting the genre to a fixed value, various. To perform semantic search, we first convert these descriptions into vector embeddings using a pre-trained language model. I'm using sentence transformer with the all-mini-LM L6V2 model. Each embedding is a 384-dimensional vector that captures the meaning of the text. These vectors are what Milvus will use for similarity search. We've now successfully inserted 8 movies. Now we define a helper function called search and display, which takes a natural language query and an optional parameter for the number of results to return, defaulting to 3. Inside the function, we first convert the query text into a vector embedding using our embedding model. This embedding captures the semantic meaning of the query in a 384-dimensional space. Next, we call Milvus with client.search, passing the query embedding and specifying the collection name, the number of top results, and that we only want the title field returned. Milvus then searches for the vectors in the collection that are closest to the query vector. Finally, we loop through the search results and print each movie title along with a similarity score, calculated as 2 minus distance. So, higher scores mean more similar movies. This function makes it easy to run semantic searches and immediately see which movies match a given natural language description. Then we test 2 examples. The first example is searching for scientific movies, and we provide the following query input. Then we get the result. Interstellar gets the high score. And the second example is searching for romantic movies. The notebook is the most fitting for this description. Notice how Milvus returns movies ranked by semantic similarity. Even if the query words don't exactly match the movie description, it finds relevant results. This is what makes vector search so powerful. In the end, we can clean up by dropping the collection. You can extend this to hundreds or thousands of movies, different embedding models, or even integrate it with a recommendation engine or chatbot. Milvus supports distributed deployment for large-scale applications, so this approach scales very well. That's it for this demo. Milvus makes semantic search and recommendation systems easy to build and experiment with. I hope this gives you a clear starting point for building your own vector-based applications. Thanks for watching.